Hello student, I am Dr. S. L. Munde, Assistant Professor, Department of Mathematics 3, RLT College of Science, Akola. So dear student, in a previous lecture we have seen some problem how to find out the coefficients of the Fourier series. That means how to find out A0, AN, BN, coefficients of the Fourier series. Okay, only we have found only we have calculate coefficient of Fourier series, that is A0, AN and BN. So in this lecture we will find out the Fourier series with coefficients A0, AN and BN. Then we will write finally Fourier series for that function. Okay. So the first example is expand the following function in a Fourier series f of x equal to mod x in the interval minus pi to pi, and hence show that pi square upon 8 equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. ओके, तर या ठिकाणी आपल्याला हे फंक्शन दिलेलं आहे एफ ऑफ एक्स इक्वल टू मॉड एक्स इन इंटरवल दिलेला आहे मायनस फाय टू पाय. ओके, या फंक्शनचा आपल्याला फुरियर सिरीज काढायची आहे. ओके, वी हॅव टू राईट डाऊन द Fourier series for this function, and also we have to show that pi square upon 8 equal to this RHS side. Okay, so we will see the solution of this problem. So we know that the concept of modulus of x, if x is greater than or equal to 0, then the value of that mod x will be the positive x. If x is negative, then the value of that mod x will be the minus x. Okay, so this is the basic concept of the modulus of x. Okay, now we will see the problems. So here given that f of x equal to mod x. So here we have given that f of x equal to mod x in interval minus pi to pi. Okay, so first we will check the given problem is even or odd function. Okay, so या ठिकाणी आपण x च्या ठिकाणी minus x put up करणार आहे. Then we will see the problem is even or odd. So put x equal to minus x in this function, you will get f of minus x equal to mod of x, and we know that the mod of any negative the value of mod of negative numbers is always positive. So here we will get the positive for all x in minus pi to pi. Okay, for all the values of x in interval minus pi to pi, this value of mod x will give the positive value. Okay, so that means the f of minus x is again mod of x, and hence we can say that from this equation and from this equation the f of x and minus f of x are equal. The value of f of x and minus f of x are equal, and hence we can say that the given function f of x is an even function. Okay, so if the given function is f of x is an even function, so therefore by using the even function theorem, so here b0 will becomes 0. Okay, so then by using the even function theorem, the Fourier series can be written as f of x equal to a0 plus summation n equal to 1 to infinity an cos nx. Okay, so this is the Fourier series if the given function f of x is even function, and here bn will becomes 0. Okay, now here we will find out a0 then an. Bn already here bn is 0. So here bn is 0. Okay, so here bn is 0. Now we will find out the a0. The formula of a0 is given as 1 upon 2 pi integral minus pi to pi, because interval is given as minus pi to pi f of x dx. Okay, but we know that, so here interval is minus pi to pi f of x, and here f of x is an even function. So therefore by using concept of the even and odd function, so this can be written as, this integral can be written as 2 times 0 to pi f of x dx. Okay, so we can write 2 times 0 to pi f of x dx. So this 2 and this 2 will get cancelled, and hence we get 1 upon pi integral 0 to pi f of x dx, because here f of x is an even function. Okay. Now we will put the values of f of x from this given. Okay. So 1 upon pi integral 0 to pi mod x dx. So we can write mod x equal to x. Okay, 1 upon pi 0 to pi x dx, because x greater than equal to 0. Okay, for all the values of x greater than equal to 0, so this will give the positive x. Okay, in interval 0 to pi. In interval 0 to pi. Okay. So if you solve this integral, the integration of x dx will be the x square by 2. So put upper limit and lower limit. So you will get pi square by 2, and this pi and the integral of this term is, that is pi square by 2. That is pi square by 2. That is pi square by 2. Okay. So 1 pi and this this pi and 1 pi will get cancelled, only remaining is pi by 2. So this is the value of an. So this is the value of this is the value of a0. Okay. Now we will find out the second coefficient, that is an. Now we will find out the second coefficient, that is an. The formula is given as an equal to 1 upon pi integral minus pi to pi f of x cos nx dx. Okay. So here interval is given as minus pi to pi. Okay. So here f of x is a even function, and also we know that cos nx is also even function. Then the product of the even function is always becomes a even function. So therefore, by using even function concept, integral of even function, so this can be written as 2 times 0 to pi this function f of x cos nx. So 1 upon pi into 2 times 0 to pi f of x cos nx dx, because this function f of x cos nx is a even function. So therefore this integral can be written in this form. Okay. Now we will put the values of f of x, that is mod x. Now we will put the values of f of x equal to mod x. So 2 upon pi integral 0 to pi mod x cos nx dx. So which is equal to 2 upon pi integral 0 to pi mod x for all the values of x greater than equal to 0 in interval 0 to pi. In interval 0 to pi. In interval 0 to pi, the mod of x always greater than equal to 0, positive value. So this can be written, so this is a 0 to pi. This can be written as 2 upon pi 0 to pi x cos nx dx. Okay. Now we will solve this integral. So equal to 2 upon pi as it is. Okay. So here we will use the product rule. First function integration of second function, that is sin nx divided by coefficient of x, minus derivative of first function into integration of second function. Okay, that is derivative of first function, that is 1, and integration of second function. Okay, that is minus sin nx upon n square, or you can write in this way: first function into integration of second function minus integration derivative of first function into integration of second function. Okay, that is first function is x, integration of second function, that is sin nx divided by coefficient of x, minus, here will be the integration side, integration derivative of first function, that is 1, and integration of second function, that is minus sin nx divided by a. Okay, so here one step you have to add derivative of second function, that is sin nx divided by n. Okay, so after second step you will get these steps. So 2 upon pi x sin nx upon n as it is, minus, so integration of the sin nx will be the minus cos nx divided by n, and before 1 n will be present there, so n into n, that is n square, and limit should be the 0 to pi. Okay, so here you have to add one step. Okay, so by using this formula. Okay, so now we know that sin nx for all the values of pi, sin nx will becomes 0. Okay, so 2 sin nx is sin n pi is becomes 0. So here this term will become 0 for upper limit, and this cos n pi means that is minus 1 to the power n. Okay, so now putting upper limit minus lower limit, so 2 upon x, uh, instead of x we will put the upper limit x sin n pi. Sin n pi means 0 minus 1, minus minus this will becomes plus cos n pi divided by n square. Cos n pi divided by n square means cos n pi is here minus 1 to the power n. Then minus sin x means 0, x means 0, so this will becomes total 0, minus minus plus cos 0 divided by n square. Cos 0 means 1, that is minus 1 upon n square. Okay, so again here you have to add one step. So then n square you can take common from this both term, so you will get 2 upon pi n square minus 1 to the power n. The value of this term is that is minus 1 to the power n minus 1. Okay, so here you will get the value of an. The value of an is 2 upon pi n square minus 1 to the power n minus 1. Okay, so by using this you can calculate a2, a4, a6 for the even value of n, that is a2, a4, a6, so you will get 0. So how will you get 0? That is minus 1 to the power 2, 4, 6, 8, even for the even term. So this will becomes plus 1. So this plus 1 and this minus 1 will get cancelled. Okay, so this will become 0. So 0 into this term you will get 0. Therefore a2, a4, a6, a8 and so on. So this term will become 0. Okay. Then for n equal to 1, 3, 5 for odd term, for n equal to odd term, so this will becomes minus 1 to the power 1, that is minus. So minus minus, that is 2 times minus, so this will becomes minus 2 into 2, that is 4 upon 1 square, 4 upon 1 square into pi. Then n equal to 3, so you will get minus 1 into power 3, that is minus 1 minus minus, that is 4, 4 upon 3 square upon pi. A5 is minus 4 upon 5 to the power square pi, in this way. So you will get a2, a1, a3, a5, you can calculate in this way. Okay, now we have to write the Fourier series. So these are the Fourier coefficients. Now we will write the Fourier series for the given function f of x equal to mod x. Okay, now we will put all these values in equation number 1. What is equation number 1? So this is equation number 1. Okay, so f of x is mod x, f of x is left hand side is mod x, and a0 is pi by 2 plus n equal to 1 to infinity means put n equal to 1, so you will get a1 cos x plus a2 cos 2x plus a3 cos 3x plus a4 cos 4x and so on up to n term. Okay, so here the odd term will exist and even term will vanishes. Okay, so in this way we can write the only odd term and even term will get cancelled. So f of x will be the mod x minus a0 is pi by 2 minus 4 upon pi will take common from this. Only remaining term is cos x upon 1 square plus cos 2x upon 3 square plus cos 5x upon 5 square plus and so on. Okay, now for x equal to 0, so mod 0 equal to pi by 2, 4 upon pi for x equal to 0, so this will becomes cos 0 means that is 1, 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. Okay, now we will take, so 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, this term as it is, we will shift this term to, or we can say that we will shift this term to RHS side, so this will becomes plus 4 upon pi, and then multiplying pi by 4 on both sides. So after adding one term, you will get pi square upon 8 equal to RHS side is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. Okay, so here you have to add only one term. That means you have to transfer this term to RHS side. So left side, and here RHS side only term will becomes pi by 2. Okay, then next steps you have to multiply on both sides, that is 2 upon pi. Okay, so sorry, pi by 2. So then you will get pi square upon 8 and this term. So in this way you can find out the solution of the given term. So this is the second problem. So you can solve as it is by using the previous problem. So this is problem is as same as previous problem. So let us see the solution of this problem. What is the problem? Expand the following function in the Fourier series, and the Fourier series is given as f of x equal to cos mod of cos x minus pi to pi. Okay, so this is the given function. Now again here we know that the concept for x greater than or equal to 0 mod of x. Okay, so here if you check, the cos x is a even function, because uh, by using the even and odd function, cos x is always a even function. Therefore here the bn term will becomes 0. Okay, so here only term will remaining a0 and an. So therefore the Fourier expansion for the cos x will given as f of x equal to a0 plus n equal to 1 to infinity an cos nx. So here f of x is a cos x. So let us consider equation number 1. So here we have to find out a0 coefficient and then an. Then we will put a0 and an in this equation. Then we will find out the Fourier series. So here a0 is 1 upon 2 pi minus pi to pi f of x dx, and here f of x is, that is, cos x. So here cos x is a even function, so then this term can be written as integral 2 times integral 0 to pi mod cos x dx. So this 2 and here 2 times integral 2 will get cancelled. So only remaining term will becomes 1 upon pi 0 to pi mod cos x dx. Okay, so here you have to note that cos x greater than or equal to 0 in interval 0 to pi by 2, cos x less than 0 in interval pi by 2 to pi. That means this interval can be written or can be break into the interval 0 to pi, and this can be written as, okay, so this can be written as 0 to pi by 2, pi by 2 to pi. So this interval can be break into two interval, that is 0 to pi by 2 and pi by 2 to pi. So therefore a0 equal to 1 upon pi integral 0 to pi by 2 mod cos x dx plus second integral pi by 2 to pi mod cos x dx. Okay, so we know that cos x mod of cos x always positive for the positive value of x. Okay, so by using this concept, or we can say by using this concept, for the value of x greater than or equal to 0, so this will give the positive value. For x is negative, so this will give the negative value. Okay, so therefore mod of cos x for x greater than or equal to 0, so this will becomes positive. So therefore 1 upon pi integral 0 to pi by 2 cos x dx plus pi by 2 to pi. The if x is negative, so then this will get minus cos x dx. Okay, then we will take the integration 1 upon pi integration of cos x, that is sin x, and limit should be 0 to pi by 2. Multiply 1 upon pi, this is again sin x, that is pi upon pi by 2. Limit should be pi by 2 to pi. After putting limits in this equation, so you will get 1 upon pi minus 1 upon pi, 0 minus 1, so you will get 2 upon pi. That is the value of a0 is 2 upon pi, is 2 upon pi. Now we will find out the second coefficient, that is an. An is given as 1 upon pi integral minus pi to pi cos mod of cos x cos nx dx. Okay, so here cos x is even function and this cos nx is also even function. The product of the even function always become even function. Okay, so therefore this integral can be written as 2 times 0 to pi cos x cos nx. Okay, now we will split this integral 0 to pi by 2 and pi by 2 to pi. So equal to 2 upon pi integral 0 to pi by 2 first bracket mod cos x cos nx dx for x greater than 0 plus pi by 2 to pi integral cos x cos nx dx for x is negative. Okay, so 1 upon pi integral of this term 0 to pi by 2. So this can be written as cos x cos nx. So here these two can be taken inside the integral. We can write 2 cos x cos nx plus dx. Integral pi by 2 to pi. So these two take inside the integral. 2 minus cos x cos nx. Minus cos nx means x is negative here. For the negative value of interval, for the negative value of the x in interval. Okay, now here we will use formula, that is 2 cos x cos 2 cos a cos b, that is cos a plus b into cos a minus b. Okay, cos a cos b, then okay, now here we will use the formula 1 upon pi 0 to pi by 2 2 cos a cos b, that means cos a plus b, that is x is common term a plus b, then cos a minus b, that is n minus 1 x dx. So this minus sign is common term. Okay, integral minus pi by 2 pi cos n plus 1 x cos n minus 1 x dx. So this is equation number 2. Okay, for n greater than 1, so this can be written as, actually this is a plus sign here in between, this is a plus sign. Okay, so integration of this first term, that is 1 upon pi sin n plus 1 x divided by n plus 1. Integration of this term is sin n minus 1 of x divided by n minus 1. Integral 0 limit should be 0 to pi by 2. Second integration 1 upon pi integration of this term, that is sin n plus 1 x divided by coefficient of x plus sin n minus 1 x divided by coefficient of x, and limit should be the pi by 2 to pi for n greater than 1. Okay, so what is the next steps? Now we will put upper limit minus lower limit. Okay, yeah. Instead of x we will put the upper limit. So this term can be written as 1 upon pi in first bracket sin n plus 1 pi by 2 upon n plus 1 plus sin n minus 1 pi by 2 n minus 1 minus second term and second term will become 0 because sin 0 will become 0, sin 0 will become 0. Okay, second term will become 0 minus second term solution of this term sin n plus 1 pi, sin n plus 1 pi into x into pi divided by n plus 1 plus sin n minus 1 pi by 2 divided by n minus 1 for the values of pi. So first term will become 0, that is sin n pi means 0, sin n pi means 0. So first two terms will become 0 and second term will becomes sin n plus 1 pi by 2 divided by n plus 1 plus sin n minus 1 pi by 2 divided by n minus 1. So this term will becomes remain. Now we will add uh, we will add sum term or cancel the sum term. Okay, so if you observe, so this minus and this minus will become plus. Okay, and this minus and this plus sign will become minus. Okay, so here sin n minus 1 pi by 2 divided by n minus 1, and this term, sorry, actually here minus, here also minus. Okay, here also minus, minus will becomes plus. Okay, so this will not cancel. So we can write two times sin n plus 1 pi by 2, addition of this term, addition of this term. Okay, and addition of this term and addition of this term. Sin n plus 1 pi by 2 divided by n plus 1 plus sin n minus 1 pi by 2 divided by n minus 1. Okay, this term will not get cancelled. What is the next step? Now for n plus minus 1 by 2 pi by 2, the value of cos sin n pi by 2 cos pi by 2 plus minus cos n pi by 2 sin pi by 2. So this will becomes plus minus cos n pi by 2. Okay, so we will use this concept. Okay, so here n plus 1 pi by 2. So sin n plus 1 pi by 2. So here only becomes cos n pi by 2. So here 2 upon pi cos n pi by 2. So here n minus 1 pi by 2, that is minus cos n pi by 2, cos n pi by 2 divided by n minus 1. This is the first term. So taking the cross multiplication, so you will get minus 4 cos n pi by 2 divided by pi n square minus 1 for n greater than 1. Okay, so this is the value of the an. Now we will find out the Fourier series for this function. Okay, now for n equal to 1, then equation number 2 will becomes a1 equal to 1 upon pi 0 to pi by 2 cos 2x plus 1 dx minus 1 upon pi by 2 to 2 cos 2x plus 1 dx. So taking integration of this term, so we will get 1 upon pi integration of cos 2x, that is sin 2x divided by 2, and integration of x 1 is, that is x 0 to pi by 2 limit, minus 1 upon pi integration of cos 2x, that is sin 2x divided by coefficient of 2, integration of 1 is, that is x, and limit should be pi by 2 to pi. Now put upper limit minus lower limit. Okay, so here sin pi by 2, so 2 get cancelled, only remaining here sin pi x, and the value of sin pi x uh, will becomes 0. Okay, minus second term pi by 2 as it is, minus term 1 upon pi sin 2 pi, so this will becomes cancel, and only term will become, that is pi by 2. So here 1 upon pi by 2 minus 1 upon pi by 2, this will becomes 0. So for the value of n equal to 1, the a0 will becomes 0, a1 will becomes 0, a1 will becomes 0. So therefore from equation number 1, we will put a0 equal to 0. So equation number 1 becomes cos mod cos x equal to 4 upon pi summation n equal to 2 to infinity cos n pi by 2 n square minus 1 cos n x. Okay, so for n greater than 1. So this is the Fourier series for the given function. Okay, so these are the two examples on a Fourier series. Okay, so you have to solve this problem as a homework. Okay, second next problem is x sin x, and limit should be the minus pi to pi, and you have to show that this term. Okay, so dear student, I will give you this problem number 3 for a homework. You have to solve, you have to read the first two problems, then you have to try to solve this third problem. Okay, so this third problem is also again same as the previous two problems. Okay, so you can see how is it solved. Okay, so you can see the step by step problems. You have to try these problems. Okay, And I will give you another homework problem, that is obtain the Fourier expansion for e to the power x in the interval minus pi to pi. Okay, so here f of x is, that is e raised to power x. Okay, so here you can use this hint. Okay, you can use this formula to uh, this formula will help to you solve this problem. Okay, so in this lecture we have seen two problems on a Fourier series, and third and fourth problem given to you for the homework.